Tilted. That's right. All right, guys. So, any questions on what we've done in chapter 3? Yeah.
Yeah. Second answer.
It's like 20 questions.
Yeah, here's that. Can you explain? What's that? Oh, there you go. On 3.2, question number 63.
So this is one that's got. Any of them have a little calculator image next to it? You know that they ask you to do it in the calculator. So if you graph this thing, actually let's go ahead and do this. Let me put it up here real quick.
I had a general question about those. Homework, do you want us to like draw the graph of calculator maybe too, or
No,
It's right there.
pretty much.
one of my first ones, you should draw all the homework. Ended up like 30 pages of homework.
Oh my God. Well, do that to me or you. All right. Let's see. This will take a while. So in this section, it's asking you to find the local max and minima. So on the test, I had you do a similar problem, but you could just trace it, and that was fine. Here, I'll show you how to get exactly the right answer. If it was a parabola, we could find that easy enough. We could just do negative b over 2a. No big deal, right? The minute it's not quadratic, the minute it's a higher power, I can't use that. There's no shortcut for that, really, that we know of. We need some calculus to help us out with that. Just wait.
Pull the camera out.
Put it over there. Screw it. Just do it this way. Okay. All right. Yeah. So I can't believe my Dolphins won.
Yeah.
Chargers won. That's nice. The one I wasn't expecting was the Dolphins. Even though I'm a huge fan, I'm kind of used to expecting the worst, so it's kind of nice.
We got them 2 years in a row.
We're all right.
Huh?
I said we got them 2 years in a row now. We beat them last year too.
Who the?
The Raiders.
Oh, the Raiders. Oh yeah, come on.
That's the
I mean, last week I think it was pretty. Well, the Chargers record, you're always like, okay, they're supposed to win, but shit, what's gonna happen? That's exciting. All right. So let's see. If you don't have a calculator, I didn't bring them with me, so just watch. Something is almost going to happen. I'm so excited about this possibility. Okay. All right, so let's see. Why is my calculator so small? It's weird. So read that off to me, that the function we're talking about on that one.
What problem is it? 63?
What was it, 63? Oh, x4 plus x squared 4. So we got x to the 4th minus 5x squared, right? Plus 4. Now real quick, before you even do anything, when you get out of this class, and actually after the next week, you'll be able to look at a function like that. You already can tell me several things about this. Give me something you can tell me about this. Yeah, good. So, you'll go. So it's going to look like that. It's going to have x to the 4th, so it's going to be up on both ends.
What shape?
I like it. So there's at most 3 turning points. Beautiful.
What shape?
And what's the y-intercept? Just for shits and giggles. 4. I love it. Right? Okay, cool. So we already know several things about this, and actually after today's lecture we'll know a few more things. So let's graph this. All right. So here's your classic butt shape. I think that came up before. This guy has been through some rough times. But anyway. Point to me. Just point out, where's the max? Where's the local max? Yeah, right there. And where are the local mins? There's a couple of them.
-2.
And it looks like they might be symmetric. They might be the same, but maybe not. Kind of depends. How are we doing so far?
Good.
Okay. So here's how you find a rough approximation. You could trace, and actually it just starts me off right there. That's what we already knew. That's the 0, 4. That's the y-intercept. Are we absolutely certain that that's where that max is?
Yes, because that's a 0.
But that doesn't mean that's where the max is. Do you understand? Yeah, it depends on if the y gets bigger, and we have a pretty good feel that that's probably true, but I can't say for absolutely certain. It might be 4.0001 off to the side. So we'll find out. And if I trace down here, I can see the min roughly is about -2 point something, and so forth. So no big deal, right? But that's nowhere near good enough. I need to know exactly what it is. So somebody help me out. Where do I go to do that? Good. Second, trace to get up into Calc. And if I want to find that minimum, number 3. So remember, one's a left bound, so you go to the left a little bit. A right bound, you go to the right a little bit. And then give it a good guess. So there's the minimum there. -225. Cool, we doing all right? And that max, we pretty much felt that let me just check that out because I'm curious now. It must be that 4. Let's find out. So left a little bit of the answer. Right a little bit of the answer. Is everybody cool with this? You guys can look here. It's a little bit bigger. And then give it a good guess. And it is 4. Cool. Okay.
That one has to be 4 though, right? Because x is 0.
Doesn't have to be. I mean, it certainly could go through. But could go through and kind of go through like that. You see what I'm talking about? I mean, that could be the intercept. I'm kind of,
I see what you're saying.
overdoing it. Yeah. There is some symmetry here, though, isn't there? If you look back, one other thing that nobody brought up is what kind of symmetry will this have? Yeah, if you plug a -x in, don't both of these just stay the same? When they square or when they fourth power, the negative goes away. So the function's the same. That's going to be even symmetry. We know all the powers are even. What power is on the variable in the 4? Good question there is, where's the variable in the 4? So what power must it be? 0. X to the 0. So they're all even powers if we kind of extend the definition of even to being not odd. 0 is not odd. It's not even either, but that's all right. How are we doing so far? Is that so? Considering that's the case, then this must be the maximum. And once you know this minimum, you also know that minimum. Now, real quick, since we have this up on the screen, at least one person told me about Zoom Box. It's one of the best things you could do for yourself. Zoom Box. And then you just kind of zoom in on the important areas. So I might want to zoom in where all 3 of these things happen. I go up to one corner, hit enter, and I start going down and over to get to the other corner of my box.
Oh, that's cool.
Enter, and then it kind of zooms in just on that piece. So that does improve tracing, but tracing is not the preferred method here. All right, the more you zoom in, the better your trace gets, but because you get better resolution. All right. So is that cool? Okay. I answered a lot more than what they asked. They just asked for the max and min. So that's all you need to find for those. All right. Any other?
Number 84.
84? Oh yeah, so here we go. This is taking that gutter problem, making more out of it, right? You want to find Actually, it's not even making a box. 83 is making a box. 84 says you gotta. You guys cool with this? You need the lights back on? Okay. You have this box with a square base. And the base is square. Right. With the edge of the base having length x inches, okay, so they already gave us this. So the square's got to have the same length and width. The total length of all 12 edges of the box is 144 inches. So what are you going to call this here? All right, you can call it H. I love it. Cool. You can call it Y. You can call it whatever the hell you want to. As long as you give it some variable name, because I don't have a clue what it is. But I do know that all of the edges add up to be, where do you go? 144 inches. So how many x edges do you have? So I have 8 x's plus 4 h's has to be 144 inches. Cool. Right. So you start attacking these problems by what do they tell me? What do they definitely just tell me for sure? They tell me that all the edges add up to be 144. So that's what they tell me. And then what do they ask me? Considering the title of the problem, they're probably going to ask me something about the volume. This is what they tell me. What do they ask me? Show that the volume of the box. Okay, so they ask me about the volume. So I want you to notice something. They gave me the variable x. And you notice how the expression they have in that part A only involves x. Cool? What's the volume of this just by this picture alone? Forgetting what we know. What's the volume of this? Yeah. Volume is length times width times height, so the volume is x squared h. Now there's a lot of hints in this problem. I could solve and get everything in terms of h, but I know I want to get everything in terms of x. Right? I want to get rid of this h. So what can I do with what I know to help me with what they ask? You got to first do what with this before you can substitute anything. Solve for h, and then you can plug it in there. Cool. And I'm making a big deal out of this because most of the word problems in this class will be something like this. They tell me something for sure that I'm going to use in what they ask me later. So h, if I solve this for h, what do I get?
144 minus 8x divided by 4.
And 4 goes into 144 36 times. And into 8 twice. Cool. So now you just got to throw it in there, and you just got to make it look the same way that theirs looks. We have volume is x squared times h, and h is this. And now you just got to play with it a little bit to make it look the way they have. You just have to take out 2. Cool. You guys get the feel for that? Write down the equation relating what they tell you with whatever you're working with. Then write down the equation, the process for what they ask you about. And start filling in what you know. So that's part A. Now part B is just what's the domain of, what would the domain of this be? This is different than the domain from just pure math. This is not anymore a pure math problem. Pure math would say the domain is everything. It's a polynomial, so it can be anything. Physically,
Can't be zero.
can't be negative. Yeah, it can't be negative. It can't even really be 0. I can't have a 0 height, because then I basically have nothing. You with me? If the height is 0, it doesn't exist. Alright? You have these atom thick things. It's kind of weird. Even that's got some height. So part B says Oh, where'd it go? What can x be then? Volume has to be greater than 0. So what's got to be true about x then?
It's gotta be greater than 0.
All right, let's fill it in. The volume has to be greater than 0, which means 2x squared times 18 minus x must be greater than 0. True? Now, and I really desperately want you guys to be with me. The domain of this function is all real numbers. The only reason that we're not doing that for this problem is because this has to have physical meaning. You can't have negative side lengths.
It has to be greater than 0.
Cool. What's it got to be?
Greater than 0.
No. Because if it was 36, that would suck, right? If x was 19, wouldn't that suck?
Oh, so anything less than 18.
What is this? This is always positive unless x is 0. So I already know it can't be 0, so I can kill this part. It's all based on this part. 18 minus x is greater than 0, so x must be less than 18. And we also already know that it must be greater than 0. So it's got to be between 0 and 18. Right, so I can make it really tall, which means the base would be really small, of course. Or I can make the base big ass thing, but then the whole thing is really short. Cool, yes, that's what that relates to. That's those extremes. And then part C is in the calculator again. Throw that bad boy in the calculator. And then you just find, when you graph this thing, let's see what it looks like when you graph this thing. So we get 2x squared, 18 minus x, Funkadelic. Okay, now what am I missing here? When you get this graph, you have to know a little bit about the function when you walk into this. So what am I kind of missing here? I can see the root related to this, the 0 related to this, right? That 0 would be 0. What's the one related to this? Where would this be 0? 18. Can I see that? In fact, even more important, the reason they gave you this problem, the reason they made this part B, was so you knew how far you should see on your x-axis. How far can I currently see on my x-axis? Up to 10. So let's make that up to 20. So we can definitely see the whole domain, right? And you'll see something interesting. If you go to Window, I can make my x max become 20. So I can see all of the allowable values of x to make this thing physically make sense. And you'll see what we should expect.
Why not?
Yeah, look at that thing. So that's a little bit better. That's really, I mean, there's no way you could, without thinking for a second about the actual function when you walk into this. When you graph that, you just think, oh, it's a really skinny-ass parabola thing. But you have to take a second and think, what am I missing here? This thing goes up so high that I can't even see where it starts to come back down towards 18. I know it's going to start coming back down towards 18 because, there you go, it's a 0. 18 makes it 0. What can I still not see, though? I mean, what's it doing between here? Yeah, that's going to be the max, somewhere way the hell up there, right? So what do I have to do now?
Raise your max.
Let me try this. This thing works sometimes. Zoom fit, yeah. Sometimes it sucks big time. Let's see what zoom fit does to us. It's supposed to fit the most important parts of the graph in, but sometimes it just really sucks. Let's see what it does here. All right, this looks pretty decent. Yeah, there you go. Cool. Exactly what I want. So this scale must be insane. Look how it looks like a thick block because it's a tick mark every one. So that scale must be insane. In fact, look at the window. Y max 5,600. Yeah.
Dang.
All right. Wasn't that crazy big. Cool. So how do I find the max volume?
Second.
Yeah, just do your whole second calc max. Left bound, right bound, guess. Cool. You with me? So, I love that. You with me? Where are you? Yeah.
Well, at 18, there will be an asymptote there, or what?
Say again, sir?
At 18,
No, it won't be an asymptote. There's no, it's not on the bottom. It just makes it 0. And you can see, I mean, what is it trying to say here? The volume here would be negative. So that's why my domain is from 0 to 18, because that's where it makes the volume non-zero, positive, strictly positive. So math says, what the hell's wrong with these numbers? And we say, oh yeah, because I'm working with a physical thing. It can't be negative. Right? It's not a black hole. Okay, so 2 things that come out of this. First thing is, when you graph something in the calculator is not able to do all the work for you. You have to kind of know a little bit about what the graph is supposed to look like before you go in. So really, the most important things here are 0 and 18. I need to be able to see those, or else I miss a lot about this, because it goes through 0 at 0 and 18. So it's doing interesting things in between there, possibly. Especially considering the whole point here is to find the max of something. I need to see that hill. Plus, you have to know how to play with your windows and when to play with your windows. Yeah, good. Okay. Is that cool?
Me too.
Yeah, it's like purple.
Yeah, what section was? It's 3.3 as well.
All right. I don't want to do all these for you. Let me see. I love it. Okay, rabbit population. A small island is a third of this.
Actually, just skip that one. Just skip number 24 and 3.3.
Well, real quick word about 82. They give you a rough graph of it down there, so you're going to graph it yourself. You already know what shape you're looking for, so you might have to change the windows so you can see that. And then it's all about finding where that rabbit is sitting. So they make this kind of like a kindergarten example of a pre-calc problem.
Why do rabbits sleep?
Part B says, when does the rabbit population disappear from the island? And that's an interesting question. And when would it disappear from an island? Of course, when the population goes to 0. So all you got to do there is find the spot where it goes to 0. And here's a nice way to do that. I don't know if I've shown you this yet. Since we have this graph here, if I wanted to, we know that 0 is 18. I know. Let's pretend like we don't know it. If you go to second calc, which one of those do you think I want to use? Hey, all right. And it's going to ask you something that sounds very familiar. It's going to ask you 3 questions. What is your favorite color? No. It's going to ask you, what is your quest? No. Left bound, so you got to go to the left of it. There you go. I got a few Monty Python things. Right bound, you go to the right of it. Give it a guess. And of course, it's going to tell us 18. So you can do the same thing with the rabbit problem. When are they going to disappear from the island? When are they all going to die out? You find out when that function hits 0. Right? So population has been a huge subject for a long time. Back in the 60s, 70s, they started to predict that we would fill up the earth and not have any room left by the 90s, by the 2000s, by the, it keeps moving because situations keep changing. So they keep having to change the formula that models the population of the earth. Right? Because there's wars and there's different diseases that come out and all these death rates and birth rates are affected. Okay. So it's really, if you ever wanted to become a actuary or a financial analyst, if you want to do this business-wise, you just observe what's going on in the world, you tweak all the formulas that relate to that thing, and you see what it predicts. And you write big reports on it to scare everybody. Or if you're in your business, you tell your boss what to set the price at so that you'll make the most money based on different things in the economy. But you keep changing your formula that has all these factors in it. So that's what you would do as a financial analyst. You make a lot of money without driving crazy. All right. That was too much. Any other questions you had?
24.
24?
Yeah.
In that same section?
3.3.
3.3?
Yeah.
Oh, okay. So I might be done with this for now. You got the basement. Fuck you, little dude. Okay. We see 24. Yeah. Okay. So this one just says use long division. Now, what's the problem with this that we have to account for when we set this up?
No X.
It's missing some terms, right? So it does have 2x to the fifth. It's got an x to the fourth, but it's got no x cubes. It's got no x squares. It's got no x's, but it does have a minus 13. Cool. So that's the part that's really easy to forget. You need those there. And really, if you forgot them, you would realize you need them pretty quickly, because then you'd have nowhere to put the like terms. There'd be nowhere for them to sit. So what's the real question here?
Yeah, just solve it, I guess.
I love it. Well, one thing that's kind of gruesome here is the fact that 4 doesn't really go into 2 nicely, right? So you could, now notice how a 2 comes out of these. So you could divide by 2x squared minus 3x plus 4. And then whatever answer you get, you still have to divide that by 2. You guys with me? Because how do you divide by 6? You can divide by 3 and then divide by the 2 that you left out. You guys semi with me? So what would I put here if I was to do this directly? 4 goes into 2, 1/2 times x squared, so what do I need there? X cubed. I don't know if this is where the question came in. Is that answer the question, or?
I just, yeah.
What do you do on the next step? I'll do the next step, and then I'll let you guys finish it up. 1/2 x cubed times 4 x squared. So it'll be, obviously it has to be this. And then 1/2 x cubed times negative 6x. Negative 3 x4. And then 1/2 x cubed times 8 plus 4x cubed. And then you change the signs. And then you keep going. So those go away. You get negative 4x4 plus 6x cubed. It's really nothing to bring down, but you can put it there if you want to for a place. And then I just keep going. Oh, I don't know. All right, I read that as a 10. That's my bad. Minus 4x cubed. Okay. That's a lot easier to handle now compared to before. But you guys understand what I said about a 2 comes out of this. You could divide by half of this, and then whatever answer you get, divide it by 2. Just put a 2 underneath all of its numbers. Not a damn thing wrong with that. Because you're doing what they're saying to do, you're just not doing it directly. That's fine. Okay?
Well, I mean, the last part is when I got confused.
Shit.
Like
All
when
right.
you got, yeah. When you
So
got
4x squared goes into negative 4x4 how many times?
1.
Negative 1 x squared. So you get negative 4x4 plus 6x cubed minus 8x squared. Change the signs. So now I must have been psychic. There's your negative 10 x cubed. That's what it is, Jeff. You didn't make a mistake. Plus 0x. Now here's where it gets, slightly discussed, but not too bad. Now you need 4 to go into negative 10. Say again? Okay. So minus, I'm going to write like this. Minus 5/2 x so negative 5/2 times 4 is your negative 10. x times x squared, x cubed. You get 15 x squared, and you get minus 20. Change the signs.
Where did you get the 15 from? I don't know.
Let's see. 5 halves times 6.
Oh.
Yeah. So now I get these cancel. Negative 7x squared plus 20x. And you can bring down now the minus 13. So I know this is going to be the last step because this is where the powers match. You know you're done when this is a lower power than this, because then it can't really go in anymore. That's where you write that rational expression at the end for your remainder. So 4 goes into negative 7 how many times? Exactly how many times? Negative 7 fourths, right? Because then negative 7 fourths times 4 will be negative 7. See how nicely that works? So we put this up here. My negative 7x squared plus 20x minus 13. So now I get negative 7x squared. See if I can do this in my head. 21 halves. I can do that one. Minus, what's it come out to be? 214. Are you guys with me on this? What am I doing there on the last step? Negative 7 fourths times 4x squared. Negative 7 fourths times negative 6. And negative 7 fourths times 8.
2 and a half, eh? 2 and a half?
21 halves. Right?
21, yeah.
Yep. So then you change the signs. And you get 40 halves minus 21 halves is 19 halves and plus 1.
So what did you do with 20?
Make it LCD with the 21 over 2. To make it 40 over 2. Minus 21 over 2 is,
Okay.
yeah,
I see.
not a big deal.
So you put it side by side, side by side. Okay.
So don't, whenever they throw fractions in any damn thing we're doing, the thing by itself is hard enough. Then they throw fractions in there, but it really shouldn't matter. We know how to do fractions. We just take a second for that individual piece of the problem and we just be careful about what we're doing. Fractions should not scare us nearly as much as it might once have. Right? But again, I would much rather divide this thing by 2 and attack it there and have a lot fewer fractions to worry about. If I were to divide this by 2, I would get twice this as an answer. I get x cubed minus 2x squared minus 5x minus 7 halves. And then I would divide each of those by 2, it would become this. Exciting.
What would you do? Say divide it by 2 first, and then when you get this remainder over that, over
Yeah, what do I do with that remainder there before I forget?
You put plus, and then you put x plus 1 over the original.
All this crap here. And officially, it's okay if you leave it like that, but you should kind of double the top and the bottom. So you have a fraction within a fraction, but that's plenty. But if you were to cut this sucker in half, you would just take everything you got and divide by 2. So I would have gotten 19x plus 2 over this. Cut in half, 19 over 2x plus 1.
Okay.
It would be the same thing. You would more than likely, though, just double these since you're, divided by 2, you just multiply the bottom by 2. Okay. So there's a straight up follow the procedure way to do things, but there's almost always here's a little tweak to make it easier to look at. Side note to those procedures, right? And that's a good one to realize. If you ever have some factor that can come out of everything, do it so that you don't end up with these fractions falling all over the place. All right. I've ruined so many of your days. That's too bad. Any other questions? Hello. Any other questions from homework? All right, so I know one man is doing homework so far, for sure. The rest of you might be, and maybe there's no questions. I like that.
I can ask more questions, but I don't know why. Keep going.
Let's just do it.
Alright, fine.
Do one more.
Alright, 3.3, number 57.
Oh. All right, so this is kind of nice. This is, believe it or not. Oh. Stay here. You guys all got this here?
Yeah.
As much as you wanted that? Okay. Which one was it again you wanted?
57 on 3.3.
57. Okay.
All sorts of fun stuff.
So they tell me that they kind of tell me that that's a 0 because it says show that they are a 0. So how do I show that that's a 0 of this polynomial? Plug it in, make sure it shows up to be 0, right? If that is a 0 of this, what is a factor of this?
X plus x minus 3.
So let me say that again, because this is the key point. If 3 is a 0 of this polynomial function, x minus 3 must be a factor of this. It only makes sense. If 3 makes it 0, x minus 3 must be a piece of this. So those two go hand in hand. Because what we're going to be doing today is finding a bunch of zeros by using a bunch of methods that thankfully will cut down our huge-ass list of zeros, possible zeros, and then using those zeros to factor the thing that we had in the beginning. Okay. So let's first, to verify this, you just plug 3 in. You guys can do that, and it equals 0. Yeah. Now how do I start to factor this then? It says find all the other zeros. Yeah, then I know that 3 will go into it evenly, right? So I can synthetically divide. And this is actually a way to do this. You don't even have to do this. Because remind me, if I divide by 3, whatever number is here, what does that mean? That's the remainder. That actually is what the function is evaluated at that number that I divided by. So let's try this. Let's see what happens. Remind me how to do synthetic. Yeah, drop the 1, good. 2, 6, -5, 15, 0. Whatever number is there, the remainder theorem tells me that that is this evaluated there. So P evaluated 3 must be 0. Okay, cool. Therefore, that kind of proves the first part of it. Right? We kind of did two things at once. We just showed that it is a 0 of the polynomial by doing this, and we're that much closer to factoring this thing. What do I know so far? X cubed minus x squared minus 11x plus 15 factors how? So far? X minus 3. Yeah. It was cubed, so now it's squared plus 2x minus 5. Looking at that last piece. Now here's the thing. I'm going to take it one more step. I don't think they intended you to here. Oh, they ask you to find the zeros. That's fine. So 1 0 is 3. How do I find the zeros of this one?
Quadratic.
Quadratic. I love it. Because can that thing factor? Hell no. You always try to factor it first, but it won't. And then I go ahead and use quadratic. I'll let you guys do that stuff. So you gotta love it when they give you more information The ones we're going to do, they're not going to tell us a damn thing. They're just going to give it to us, and it's totally who knows what. But here they at least told us one thing that works. Thank God. Got us rolling. Okay. So, let me do this. I'll throw something at us, and we're going to talk about it as we do it. Actually, let me go. Yeah, do this. The last couple things out of section 3.4. Bless you. Anybody know what Descartes might have contributed that you've been using ever since possibly Math 90?
Dreamed out? Dreamed out? Any of his dreamed out things? Like
Dreamed out?
numbers aren't really there or something?
Possibly. But I kind of underline that part of his name for a reason. I'll let you guys know the name of the XY plane. What's the official name of the XY plane? Cartesian. All right, so Descartes is the one that came up with that. Now, Descartes did a lot of stuff. That's one of those names that kind of pop up every now and then. He just kind of did a little bit of everything. Sort of like somebody named Gauss and Euler. These guys' names just keep popping up. They had way too much time in their hands, so they just did this stuff. Here's one of the weirder ones. I'm going to teach you this, but I'm going to be very honest. It's one of those things that sort of seems like it might be useful, but it isn't really. But I got to show you. I got to teach it to you, and I want to explain kind of like why it works the way it does, and then it leads to a much more useful tool to use. So here's what Descartes' rule of signs says. If I have something like this, let's do something. All right, sorry. Jeff, come on. Oh, stupid. So let's say this is p of x, right? This is the polynomial function that we're looking at. If we have something like this, let me just ask you this and see what you think about this statement, this question. How many times does the sign change as I move from term to term? How many times do we see a sign change? Well, see, 4 is positive here, and then it becomes a negative there, right? So there's one sign change. It doesn't change here, it doesn't change here, but so there are 2 sign changes. How are we doing so far? All right. What this means, what Descartes figured out, is that either there are going to be 2 or 0. It always goes down by an even number. So there's either 2 or 0 real positive zeros. Let me let that sink in a little bit. So if there are no real positive zeros, what might there be instead? Yeah, good. Complex numbers. There might be complex zeros. That's why it goes down by 2 every time. Let's keep going. I'll show you. What's p of negative x? This is sort of like looking at symmetry. What's p of negative x? Yep. If you plug a negative in, which one of these will change sign? Yeah, anything that's to an odd power will change sign with me. Because you raise a negative to a 4th power, negative goes away. So this is going to change sign. So now it's plus. This is going to stay the same. This is going to change sign. And this is going to stay the same, of course, because it's just 2, no matter what. So this is really the same kind of thing as when you check symmetry. You plug a negative x in to see what comes out. But now we're going to look at it the same way we just did. How many changes in sign are there? Yeah, there's 1, 2. So again, there could be 2 or 0 real negative zeros. So I want you to think about this for a second. If I have something to a 4th power, isn't it possible? I mean, what's the least number of real zeros, period? What's the lowest number of real zeros this thing could have? 0. And what's the most? 4. Right? Because it could have 2 positive and 2 negative. How we doing so far? And it only makes sense. What could happen with a 4th power? We know it should look sort of like a butt. So it might be something like this. Well, that looks a little too much like that. Might look like that. In which case, how many zeros does it have? No real zeros. It has only complex zeros. You guys with me? Cool. Okay. So that's really what this thing is saying. You can see how Descartes' rule of signs is not very powerful. I don't know, maybe you can. I don't know if you can. It doesn't tell me which one of these I'm in. It just tells me it's possible you don't have any real answers. And it might be only complex answers here.
My question is, you said that there is 2 really positive zeros. Can you show us on the drawing what you mean by this?
Oh, so it could be, if I just move this down a little bit,
Yeah.
couldn't it have 2? Oh, I'm sorry, let me make it a little more specific. It could have 2
Real positive.
real positives, so it'd be like this. You can do it, Jeff. It'd be like that. So it has 2 real positives.
So this means like this.
That's what that would mean. If it had 2 real positive zeros.
This is necessary because they are two changes from change of sign twice. It should be positive. It should be positive and zeros, or it could be positive and negative at the same time. This is my question.
It could be, yeah, yeah. And the other situation, so again, what are the possible things that could happen? I could have no real zeros, which is this. I could have 2 positive or 2 negative, right? Or I could have 2 negative and 2 positive. You with me? The only interesting thing that this does for this particular problem is there's no way it could be, I almost drew this, there's no way it could be this.
Yeah, this is my question.
Because then there will be 1, right? And then, is it possible to have 1 negative 0? No, it says you can't have just 1 negative 0. So I can't have that.
This is my question.
Okay, cool. Yeah.
So that graph, you can never get a graph like that?
Not for this problem, not because of the sign changes that we see. There's no way that this could be like that. Because is it possible for there to be 1 negative 0 by itself? No. So the graph could not look like that. Now, this is very interesting. It took a lot of work. It is useful sometimes if again, it's really weird to be talking about something. I want you guys to understand it, but at the same time I want you to realize it's not practical for most things. It does help in certain situations. If I had 3 or 1 positive real 0, and I was trying out for my list of possible zeros, I was doing synthetic division, and I found 2 positive real zeros. I know that there has to be 1 more, don't I? Could it be only 2 positive real zeros? No, it has to be 3 or 1.
Maybe at the same time, at the same position. Correct.
Could it be repeated? Yes, you're right. It could be repeated. But when I do synthetic division, it would just mean that if 2 goes in, 2 could go in again. So mathematically, repeats aren't hidden. I could just divide by 2 again. Visually, repeats are kind of hidden because I see it touch once, but there's actually 2 answers. So that's a good point. But synthetic division, I'm going to have to do the synthetic division. I'm going to see it happen. Yeah. Okay. Maybe. So how can I make, maybe you guys can help me. How can I make a function like I just did that would have this happen? I'll help you out. It can't be a, one way to make this happen for sure would be a 5th power. Just imagine any odd degree, odd highest degree functions, they have to have at least one real answer. And there is one key piece that's missing for me to really make this picture complete. And let me talk about that real quick right now, before we do that. And this is the part that people seem to miss easily. Can somebody create a quadratic that will have no real answers, no real zeros? How would you do that? And think about this. Which part of this actually has the most to do with what I just said? In fact, the only part of this has anything to do with what I just said. Yeah, b squared minus 4ac. So if b squared is less than 4ac, you're going to end up with complex numbers, right? So can you come up with a quadratic that would do that? Here's my ax squared bx plus c. So if I put bx first, let's make bx small. That makes sense. Let's make b1. Now we're almost guaranteed. As long as I don't make a and c opposite signs, I'm okay. Because then it would be plus, and there's no way I can get a complex number then, right? Okay, so what could I do here? So a, give me a suggestion for a.
1, 2, x squared, x
2, I like 2.
and c.
4.
Now then c better be positive, right?
Yeah.
And 4 works beautifully, I like it. So now this has how many real zeros? Yeah, none. In fact, look at what Descartes, here's where Descartes' rule of signs is the best, which we can kind of truncate Descartes' rule of signs to be most immediately practical. Anytime there are no changes in sign, how many positive zeros will there be? What does Descartes say? Yeah, it's equal to the number of changes in sign. Do I see any changes in sign? No. So what Descartes says is the number of changes in sign in P of x is equal to, or, oh boy, I love this, or go down by 2 each step, is equal to, or down by 2, the number of real positive zeros. Now, the second thing he says is the number of changes in sign of P of negative x is equal to, or down by 2, the number of negative, real negative zeros. And that's nice. It kind of makes sense. Leave the x positive, good. Make it negative x, that relates to the negative zeros. It's kind of nice. The point I want to try to make here is, why does it make sense that it goes down by 2? If I see 3 changes in sign, why is it 3 real zeros or 1 real zero? How do complex numbers always show up? The minute I get 1 complex number, I actually have to have 2. So they always show up in what's called conjugate pairs. In this case, complex conjugate pairs. What's the only way I can get a single answer from this? One numerical answer. We know it's got multiplicity too, but the only way I can get one answer from this is if what? What's the only way I can get one answer? Why do I get 2 answers normally here? What piece of this? The plus or minus. If I was adding or subtracting 0, then I would just get one number, right? You guys realize that relates to this case here. Then the vertex is the root, right? Then negative b over 2a is the root also. So that means this piece must be 0 then. Maybe. So if I had this guy here, how many changes in sign do I see? 0 changes in sign. So there are 0 positive real roots. If I do p of negative x, how many changes in sign will I see? What's p of negative x?
1.
Yeah, p of negative x. Now be careful. This stays the same. This becomes negative x. That stays plus 4. I see 2, thank God. Because what does that mean? There could be how many real negative roots? 2 or 0. And we know the answer is 0 for both of these, right? The way that we created this, didn't we create it to have no real roots? Yes, remember we did the whole b squared minus 4ac thing so that it would come out negative? So it'll only be complex roots for this thing. Okay, cool. Maybe. So here, last example of this. Dude. So, trust me, I will give you a problem like this on the test, and I'll ask you one thing. I might ask you, use Descartes' rule of signs, like we're just about to, and tell me what you see. Tell me what it means about the roots. Right, I'm not going to say, now, tell me the end behavior, factor it. This is kind of an ugly monster. But you can tell me one thing about this, just by looking at it. How many changes in sign do you see? 1, 2, 3, 4, 5. 5 changes in sign. So how many positive real roots could it have?
5, 3, 1, and 2, right?
Yeah, it could be 5, 3, or 1.
Oh, yeah.
If you go down by 2, that's negative 1. You can't have negative 1 roots. It's a little weird. How many apples you got? Negative 1? That's weird. So you got to stop at that. You with me? So what does that tell you then? Could it possibly have only complex answers? Of course not. And it only makes sense. Complex answers must show up in pairs. How many total answers are there? 7. Therefore, it can't only be complex. It's got to be at least one real answer. You with me? So again, I really want you to understand. It's good to go through Descartes' rule of signs. It's good to know it. Sometimes it actually helps out a lot. Most of the time, it's just a side note. And I will be totally honest about that. It really is. But in this case, it tells you whenever you have an odd number of sign changes, you're guaranteed to have at least one real root. It can't possibly be only complex. And then to check out the p of negative x, just to kind of complete this idea, every odd thing is going to change. So what's going to happen here is interesting.
Oh, no.
You guys cool with that shortcut? I mean, only the odd power thing is going to change sign, of course, when I throw a negative in. It's the only way the negative can survive. What happened there? How many sign changes do I see?
0.
None. So how many negative roots are there?
0.
Yeah, there can be 0 negative real roots. How many complex roots am I guaranteed then?
A lot of them?
Nope. How many am I guaranteed to have?
0.
Did I miss something?
2 plus
Yeah,
6.
the x shouldn't be negative.
Oh shoot! I forgot. I was trying to force it to be a certain way and I didn't. All right, so shoot. You guys cool? You got to plug your negative x in there. Good catch. So how many sign changes are there really here?
1.
2.
2.
Aren't there 2 sign changes?
Yes.
Yeah.
It's plus 8, minus 1, plus 1. So there's 2 sign changes. So how many negative roots can there be? There could be either 2 or 0. Okay. I was excited for a second. I thought I would just put it together, right? So there could be 5 positive real roots, and there could be 2 negative real roots, which means how many complex roots would there be then? If there were 5 of these and 2 of those?
7.
That'd be 7 total roots. How many left over for the complex guys? None.
None, because complex.
Okay, maybe you're with me. And now